Thank you very much, Chris, for this. See if this works again. Seems to be working. So good morning. I think somewhat one before last for lunch, cybersecurity. Cybersecurity has been mentioned a couple of times, I think, in the different presentations, but I think what I wanted to do here is to give a slightly different perspective than the previous presenters. I took basically a perspective which is a little bit global in the point of view of where cybersecurity standards are developing, how those basically developing standards are to be understood from both the perspective of manufacturers taking into consideration digital, and also, of course, from the perspective of the digital manufacturing platforms under development, and then the different projects consideration. So there's a couple of these backgrounds. People might know me in the first place from the organization called ULSEC, which is an association of IT security companies that has been around for about 2 decades. And since about 10 years, we've also been working with about 600, 700 manufacturing companies directly in supporting their digitalization. So taking a couple of steps back, I think we've heard this morning already quite a lot about standards. I think it's sometimes very difficult to really understand what all of these standards mean, how we can use them, how we should be able to use them. And we talk about national standards, international standards, industry standards, de facto standards, and so forth. So it's pretty complex environment over there. And what I definitely wanted to do here is to give a bit of an insight in trying to understand which forests to walk in and which trees that you should shake in order to maybe make sure that your projects, developments, and even manufacturing environments are up to the latest and greatest in those perspectives. So trying to go forward, not to go back. So I call them cybersecurity standards considerations. The international, the European cybersecurity standards, de facto standards, we have industry-specific ones, which could be user orientation driven, or could be technology driven. We have non-industry specific standards, like the NIST and the ISOs. We have regulations, which basically start to utilize somehow many of the standards, like the NIS directive is mainly referring to ISO 27000 as a base layer in a number of the member states. And while GDPR is also focusing towards ISO 27000 and specifically the privacy component of it, there's governmental regulated ones, like in sector specifics, for instance, nuclear, air traffic, healthcare, telecoms. There's national specific ones, like we've seen the one from DIN just a little bit earlier. And then there's what I call new approaches, and we'll talk very briefly about many of those, but I'll try to focus in any case on a number of the more important ones throughout this scheme. Maybe a final one here to consider is some specific cybersecurity related evolving components, like vulnerability databases and responsible disclosure information, which is very important for those people working in cybersecurity space on a day-to-day basis. We'll also consider, of course, in the first place, the main component. So where does this have to start from? And most of the cybersecurity and security frameworks start from a holistic perspective, namely enterprise risk. What does this really mean for you? I mean, you can really go into very many depths about securing the very final highly encrypted small type of communication layer, where that might not be very relevant for the core of your business, which might include the operation of a digital factory. And so maybe the better thing there to consider is how you can secure your operational systems from, for instance, prevention against malware attacks that might enter in to the building through USB sticks too. And don't even consider that those things have been going outside of this world, because they are still very much there. Also definitely to consider in this case is the human risk. Next to, let's say, the outside dangerous internet, there's the human that brings in a USB stick, but also that has started to do an implementation, leaves open some test sites and some test ports, and then basically forgets to close them, which then usually ends up in data losses and considerations that haven't been there. Business risks, product development considerations, and an important one, which I think is definitely for this domain coming up much more strongly, excuse me, is the concept of shared responsibility. Shared responsibility is something that is probably coming much more out of the cloud environment, but is by now also being adapted by IoT and different types of software development, as we can see it happening, where many of the APIs basically are being developed from within the cloud to some extent. So utilizing GitHub and other platforms to do those developments. So I'd say also something very much to consider. And then the incident management capabilities, of course, and components which have to be considered when, in this case, manufacturers are looking towards what their peers are doing, or maybe also like some industries could be regulated specifically. For instance, the case for operators of essential services related to the NIS directive. So many different considerations to be made when considering cybersecurity standards. There's also, of course, the consideration that we can take more from an overall perspective of the different standard development organizations. And so to name just a couple of them in order of relevance and importance, I would even say international industrial cybersecurity standards, and then I'll take those a little bit more in depth as we go along. So there's the ISA 99, IEC 62443, which is probably for most manufacturing entities the most important one, because it really considers industrial control systems, SCADA PLCs, but only to a lesser extent it will consider newer types of developments such as industrial IoT or cloud. There are considerations being made today, and some extensions will be made to that specific standard moving forward. But you see that this is really a traditional one that has been around already for many years. Organizations can certify against this IEC 62443. People can be certified on their knowledge skills about the implementation, about the guidance of auditing systems and manufacturing environments to this specific industry standard. So, which is a good thing, but taking into consideration that it doesn't cover everything really. There's some others like the NIST standard, which is the North American industry standard, which is basically a semi-government body, mainly from North America, that's defining what those standards would need to be, of course, in consultation with the industry. And then there's the CIS, which is the basically sets up a series of controls, and some of those controls we've also been using for the connected factories activities in the previous project, and will continue doing so moving forward. And then there's a number of international standards to be considered, like ISO, and in this case definitely also considerations about ISO 27000. So moving a bit along here, another consideration to be made is some of the what we then call de facto industry standards being developed, like the ones being developed in this case, for instance, from the platform industry 4.0. We've learned a little bit about this just before, but also some others like the Cloud Security Alliance, like the Industrial Internet Consortium, OWASP. So many different names that are important in this consideration because they are de facto industry standards. So people do recognize them for many industries as, yes, we will start to utilize them. Also important in this case is to consider that many of the previous ones are either coming through member states and international organizations like ISO, many others coming from the industry, but also quite a number of them coming from industry working groups or specific vertical industries, like Namur is a group working mainly from within the process industry, or WIB, also mainly coming from the petrochemical industry, for instance, also from in the process industry. So that's where the end users are going to try to define their own set of standards for cybersecurity and requesting from the manufacturers and the vendors to live up to a number of the standards that they are deploying and developing. And then I already talked a little bit about some others. So cybersecurity to be considered in digital manufacturing platforms, but to a wider extension, obviously also towards manufacturing and digital manufacturing. And in the first place, I'd say this is something that I think we all need to reflect upon every time again. So the basic NIST cybersecurity framework takes into consideration those 5 main building blocks: identify risk, protect against those risks, detect where potential risks might be coming from, respond or mitigate them, and then recover from them if there's any level of incident that has happened. Usually what we find is that many of the cybersecurity activities are only focusing on 1 or 2 of those specific components. So it's either on protection, it's maybe more towards the recovery, but it needs to be, let's say, this full circle, because otherwise we'll leave gaps in cybersecurity. And I think that's an important one to consider. Cybersecurity is a complex arena of different technologies that are being hooked against each other and that are not always that easy to see. There's a number of other entities and institutes like the CISA, which is also North American, but they've defined the NERF, for instance, which is defining really the highest level, if you would take it that way, for cybersecurity for manufacturing, namely for nuclear. So in the nuclear domain, if you're able to cybersecure yourself against those level of standards and requirements, then you're probably doing a good thing. But in most digital manufacturing plants and environments, that's probably not necessary or doesn't have to be the case. Then the second one to be considered in terms of order of importance, as I already mentioned, is the ISA 62443 family of standards. So it's really a group of different standards that are taken into consideration how a manufacturing environment really looks like from the inside out. And so then takes that into consideration on trying to segment the different layers of an industrial environment. And that's really where this is different from other standards, like, for instance, ISO 27000, where ISO 27000 is much more related towards information security. ISA 99, in this case, is much more focused towards operational security components. So really focusing towards industrial control systems and all of the components that are linked to those. So the main message here is to try to segment those different building blocks. Like, for instance, you have a central enterprise network, you have a demilitarized zone specifically for industrial enterprise components, which are maybe not that core, and where you might need to be able to touch upon in terms of getting data out of the plant. But getting data out in order to visualize it is maybe something different than really to go into these enterprise core manufacturing systems that you need to control from the outside, and where you might need to change basically how, from an operational side, those plants need to operate. So that's an important one to consider. From this consideration, and also from the previous one, NIST has developed an extension to this together with CIS, so the CIS controls, and basically CIS controls are considering specific for industrial control systems those 7 steps in terms of being able to monitor and respond. So this might be a little bit small, but when you download the slides later on, you'll be able to see much more in depth. So where do we find digital manufacturing platforms? Basically all over the plant. And that's, I think, also one of the considerations that we need to make when thinking about the digital manufacturing environments that we are putting in place. So security needs to be, in this case, all over the place, and needs to be considered strongly when we put those digital manufacturing platforms in place, that they are taking into consideration those segmentation layers. And usually that's not the case, because most of the digital manufacturing platforms are taking us back into the cloud. And that's, of course, immediately one of the limitations of today's IEC 62443 standard. So we've taken all of this in the Connected Factories first platform, considered that in a manufacturing environment, there's different pathways and there's different stages that manufacturing companies need to mature to. And I think it's also the case for the digital manufacturing platforms. And that's the reason why we consider basically cybersecurity as a pathway in itself. So taking this concept a step further is the reason why we considered different threat models which exist, and there's many different threat models. A threat model is basically what you use in order to identify potential risks, threats in this case, from the business side, from the enterprise side, and maybe in this case also from your system side and from the digital manufacturing platform side. So taking all of these different steps really are necessary for any implementation in a manufacturing environment. We can take this from digital manufacturing side, limited to the digital manufacturing platform, and then considering all of these different components. Now, this is an example of a threat model. There's more than 12 different threat models that you can follow. This one is probably one of the oldest one, but it's still very relevant. So take into consideration how you can spoof, for instance, a system, a digital manufacturing platform system. The CIS controls are the ones that are being utilized in order to make sure that we have different technologies that we can utilize to control the different cybersecurity challenges or security challenges. So there's basic ones, there's foundational ones, and then there's organizational ones. For all of these different controls, we can come up with specific components and solutions. And that's also what we need to consider in the digital manufacturing platforms. And I've heard a couple of times today some very specific pointers in the considerations of the platforms, like identity and access management and the way that, for instance, federation would be applied there, or like in the case of the international data spaces, basically the exchange gateway for the industrial data, which is of course fine, but take into consideration that there's also the backends of those industrial environments that need to be secured, and then specifically also the platforms, of course, that provide this. So this was the previous cybersecurity pathway that we developed on the basis of these different controls, following different levels of maturity of a digital manufacturing environment. So the baselines are the ones in red. So these are the ones that you absolutely need to do. And then the orange ones are the ones to take into consideration that are not always there. So we do see that there's continuously forgotten to be logging and monitoring as components. But in other platforms, we see that there's a lot being done in terms of, for instance, privileged accounts, database integrity, and then there's sometimes things forgotten in terms of the very basic things like malware protection. So the different levels of this to take into consideration. Some component in terms of standards I would like to point out specifically, because it's a manufacturing profile which is derived from the original NIST, and it's called NIST Tiers 8183, and which is taking into consideration those earlier 5 building blocks that I suggested, but it's applying this into a manufacturing environment, still taking into consideration both the operational entities within the manufacturing environment and including there also the information technology side. So this is trying to combine from a manufacturing environment those two worlds. And then there's a couple of use cases specifically related to this, which are part of the NIST tiers environment in this case. And I already mentioned it, most of the current traditional industrial control designs are not really considering, let's say, the future, as we are talking about Industry 4.0 related, and also manufacturing, digital manufacturing environments. So it's only considering small sets of components where we see that in today's environment, digital manufacturing environments, they're spread all over the place. So that's a bit of a challenge in that consideration. So this was a Forrester approach to these different things. And again, here we see that there's a need for security on all of the different stages and levels. A consideration which was made by Trend Micro in this case is to how to evolve the Purdue model. And the Purdue model is basically the baseline for IEC 62443. So the second one that I showed you earlier on. and just showcasing where there's different risks and components that we can use to build upon. So take these different threat models into consideration for your analysis of your own digital manufacturing environment. I'm just focusing you to what has been developed already in 2016 by the Object Management Group's Industrial Internet Consortium. They've developed an Internet Security Framework, the Internet Security Framework Architecture, which is considering both an IIoT view, as in the Industrial Internet Consortium, but also a functional view and then a specific security framework. I think today this is probably one of the more in-depth approaches to utilizing security from all real levels of both business as well as systems. They also take into consideration many different connectivity components and layers. And here we talk, for instance, about, standards which are being developed in security for OPC or security in terms of DDS, things which are usually overlooked in. There's also some considerations being made into securing MQT. So again, this is specifically technology oriented, so technology standards, if you like, which become like OPC UA, a de facto standard for many organizations. And that's usually a challenging one, because we see many manufacturing companies today that they try to secure OPC UA, and then they again forget about many of the other components in there. So a risk-based approach is very useful. Things that we see evolving, IoT. There is today an IoT ETSI standard, but it's mainly intended towards consumer IoTs. And this standard has been developed mainly for manufacturers of IoT devices. I take it now and I present it to you as the code of practice for consumer IoT security, which was originally developed by the UK Department for Digital Culture Media, but it has been taken along by ETSI as basically an ETSI standard, so a European standard for IoT. And the reason why I'm using this one and not the ETSI overview is because this one gives a very good visual perspective on how IoT devices should be manufactured, and where you as basically builders of manufacturing platforms, or when you do implementations, you should consider when connecting to IoT sensors or IoT edge devices to take all of these 13 components into consideration, whether the IoT devices are following all of these different rules. I'm not saying that those devices need to be consumer IoT devices, but if they need to work for a consumer, then at least they would need also to work for an industrial purpose. So take those into consideration as well. And then we have an interesting development undertaken by the platform Industry 4.0, which is, as Olga was showing earlier, taking a holistic perspective also for security. And they're referring in the guidance that Olga showed just before, pretty holistic perspective in many different standards out there, like similar to the way that I've showed you. I've gone a little bit more in depth, but still. But there's also an interesting development, I think, which can be considered, and that's using the administrative asset shell, the AAS, as a component to use, in this case, attribute-based access control. So we can indeed consider using the AAS to add to that specific regulations and regulations on how to use a specific device or component which is part of our Industry 4.0 type of environment. And like it was shown in the very first presentation by Mondragon, if we are starting to utilize AAS, then we can consider using AAS also for not only ABAC, but maybe also for other security controls, like what are the specific security challenges, vulnerabilities, which are related to a system, a device, or something of a kind. And I'll try to close in a couple of minutes. The vulnerability attack framework that I would like to draw your attention to is becoming more a standard in terms of the attack framework. But there's now a specific framework specifically for industrial and industrial control systems. Excuse me. The attack framework is a sort of a de facto standard today utilized by many incident management responders, security operation teams, and it's using many of the different challenges related to operation centers for cybersecurity. So these are relating to what's really happening out there in the systems, and how can we see and discover how malicious actors, hackers if you like, are utilizing different vulnerabilities, and what is their way that they are using those to hack into our systems. If we understand this, if we understand these scenarios, we can better protect ourselves against those. So that's the reason why attack here is very important to consider in the way that this is being applied. And our near to final one is one which is under development, which is the Cloud Security Alliance IoT Cloud Security Perspective, because this is really also considering how IoT devices are, in this case, need to be touching base upon shared vulnerability activity. So how can we share responsibility for, in this case, a manufacturer, the digital manufacturing platform designer, and then basically also the operator or the integrator that has been putting this into operation, and then finally the end user. So where are the different responsibilities for everything, and how can we distribute those responsibilities going forward? I would like to point you also to works under development. So there's the certification framework which is now in place, and where ENISA needs to play an important role in defining this. And one of the components there will be likely industrial systems, and then specifically industrial IoT as one of the first level of certification. So in first place, there will be common criteria. ENISA has been giving out some guidance already in that space. They have published a specific Industry 4.0 guidance. So where do operators and manufacturers need to look into? Also something which is definitely relevant to look into from the perspective of digital manufacturing. I say that this is probably one that I would like to consider all of us to start using. It's what we call a software bill of materials, and all of those of us out there developing platforms like digital manufacturing platforms, what we need to consider is building out really a list of what is included in my software, what's included in my platform, and how can I assure to my end user that he understands where the different components are that he needs to look into. So like in the case of this BMW, it's composed of many different components. Like digital platform is composed out of open source technologies, specific developed and engineered components in that platform. And so we need to think carefully on how to use all of the different systems in place there to secure it. Reference integrity manifest is another way to look into this. And so how does it work? If one operator can see today only this little part of his platform, he knows it connects to many different components out there. But in reality, it connects to many other types of services, both open source services, maybe GitHubs and so forth. And the operator or the end user doesn't always have the visibility there. So providing some more transparency in the developments is really where we need to go.
Ulrich,
and getting to the end. Yeah, I'm getting there, Chris. Excellent to point it out. So the final slide. I think what we've done is we've taken a look into the different projects, mainly the ones in ICT 07, but also taking a look into ICT 08. And the work is ongoing. We've reached out to the different projects. We've been able to already taking a look into the EFPF project. And we do see that they're already applying many of the different standards that I've mentioned already today. It would be good to get a good overview of the different standards that they are applying. And definitely already I learned today that some of them are considering also many different identity and access management standards and authentication standards, which I have not yet taken into account in this list, so we'll add them. And then there's of course the new standards coming up, like the one from the industrial data space. We've also taken another perspective, and that is specifically where the different projects are having impacts in different platforms. So where we know that, for instance, DigiPrime is considering using PLC systems, but in this case, for instance, Zero Defect is also considering AI, and so that's the reason why we also should consider another approach that might be of impact here. So the very final slide, then, Chris, is point everybody out to some follow-up activities that we'll have, which I couldn't cover in the last 20-25 minutes that I've been talking. And that's really about the crisis conference where Sequoia, which is one of the ICT08 projects, is presenting its security perspectives from the industrial use cases, from cyber physical, and then from more an information security workshop relation. And we will have a standardization security workshop on the Cybersecurity for Robotics conference on November 19th and 20th, where we go into depth on all of these different standards and also how they will be developing. And then January 20th, we'll be using connected factories with a real cybersecurity workshop on developing frameworks and also where we see the certification frameworks coming up. So that's about it for me and how to connect us going further.